the limit comparison test. What about a limit comparison test? A limit comparison test, you can say some series converges and we use something to compare it to when you look at the ratio. Now we're like, man, we're getting way out of hand here. When would we want to use this? I'm saying we want to use this when you take something, sometimes it's easier to look at the limit of something to have something. I think in these problems, most of them, if they involve something like a radical. So I want to give a problem like that. And this is an 11.4. This is number 17. All right. This is what they have. N equals 1 to infinity. They got 1 over square root of n squared plus 1. And we want to determine whether or not this converges or diverges. Okay. Hey, integral test. Well, do you know how to do that integral? Okay, very good. I see that you're like, I don't know. That integral's not so easy, is it? 1 over radical n squared plus 1, maybe something from trig substitution. So hey, no worries though. Those other problems, but this was flat out easy. That was great. Crank out the integral, but maybe the integral's a little weird here. So I'm looking at, well, what about a comparison test? Well, this daggone square root's bugging me. Let's look at the limit comparison test. I think it's real easy to deal with when you have something that was like a comparison, but we have this radical in here. So, 1 over the square root of n squared plus 1. I'm going to hide this. What would that be simplified? That's who I want you to compare it to by doing the limit comparison test. What would that be? Simplified. I'm hiding that plus 1. Yeah, 1 over the square root of n squared would be 1 over n. So let's call this the a sub n. Remember, that's the series a sub n right there. Draw an arrow. And let's use b sub n, which will just be n equals 1. And b sub n is just the sequence part. 1 over the square root of n squared. I'm going to let you all copy that, but then we're going to simplify it. We're going to compare it to that. Well, what is 1 over the square root of n squared? 1 over n. Again, you might be going, oh, we do this in a comparison test. Yeah, but we might run in that jam again. So I'm avoiding it. So, when you look at this ratio, the limit as n approaches infinity of a sub n all over b sub n. Remember, these are just the sequences. And by the way, you can write this like that if you want when you write this out. All right, let's see what we get. Well, what's the limit as n approaches infinity of? So this should be easy because you get these radicals. 1 over the square root of n squared plus 1 all over. You want to use that one or that one? I don't care. How do you deal with that? That's a complex fraction. What can I write that as? That's 1 over n. I flip it and I get what?
N over.
I'll put a dot, n over 1. And when I want you to send this baby to infinity, does anybody know what this limit would be? I'll write it again. What's the limit as n approaches infinity of n over the square root of n squared plus 1? Oh, we were talking yesterday. If anybody in here, if you want to use an old cool method about limits, who liked L'Hopital's rule? Some of the hands are going up. If you like L'Hopital, you can always use it. But I think a lot of you, you've seen so many of these problems where we just got to think about it, right? To know the limit. And you're like, but you can always use L'Hopital's rule. Take the derivative of the top, take the derivative of the bottom, check it out, plug in the number. But do you see where this limit is? Where's this going? What's the square root of n squared again? And what's that coefficient to it? There's a horizontal asymptote on this. This thing is heading towards a what? A 1. Now, look at this cool limit comparison test. It says this series will converge if that limit is equal to some limit L and that limit is greater than 0. Now when that limit right there, is that number greater than 0? Yeah. But the trick is, let's follow the limit comparison test really carefully. What's it say? It says our series will converge if the limit of that ratio is greater than 0. It is. It's a 1. And if the summation of b sub n converges. Hold up. Hold up. What's going on with the one we compared it to? What do we know about that guy? That's the harmonic series, or that's the p series with p equal to 1. That thing diverges. No worries. Look at the second part. This is what's so great about the limit comparison test. You might like this better than this one. We're saying as this series diverges, if the limit, just like before, is in some value 1 greater than 0, where L is 1, and if the other series diverges. So what I'm saying is, I know whether or not right now, because I got this. Once you do the limit comparison test, what's so great about this test is, all I have to do is know whether or not this guy diverges. If this diverges, this diverges. If this converges, this converges. That's what's so cool about the limit comparison test. You know? And this does what? This series diverges. So when I'm going to write out my final answer right now. So no, this is what I'll write. This series right here. I got enough room right here. This series, and I call it summation of a sub n. This series diverges by the, let's abbreviate it, the limit comparison test. And I made a note that this diverges because it's a what? It's a harmonic series. This diverged, so this diverges. Now please note something. What if this baby over here converged? What would I have written? Because this series converges. That's what's so great about the limit comparison test. We don't get tripped up by this what? Greater than or equal to, less than or equal to. Cool. And you all are good. You're all good. Any question? Go ahead.
Do we have any time, or do you want Thursday for the test?
We will have a little time. But I would like to take the last portion of this class, like right now. Let's just look at what we've had so far. Because it starts to what? Build, and you go, hey, I'm just going to stay organized. And that's what this document's for, just for your study. And you're like, as long as I stay organized, what have we had so far? And I'll write these on the board. We've had the geometric series. We've had the test for divergence. We've had the harmonic series. You might include that as a P series. We've had the P series, integral test. And at the integral test, we did the what? Comparison test and the limit comparison test. And so, to start out with, let's put all those down. We can abbreviate them. What were they? Geometric series test, test for divergence, harmonic series. So easy to see it, right? Might as well put it down. It's so easy to recognize a harmonic series, 1 over n, right? Integral test? Do you want to include P series because they're so cool? Let's do it. P series, we can call it the P series test. And we had 2 more today. Comparison test and the limit comparison test. And I just want to start out with some. You ready? So, Connor, we'll just throw some down and let's look like, we'll go through the list. You can start with this one and go in this order if you want. It would be totally fine. Unless you just love integral tests. And you're like, I'm going to try to see if I can integrate anything first. But I'm serious, this order will work. So I'm going to start with this one. I'll go 5. All right. That's my first. Now don't worry, don't feel rushed here, Katie or anybody, but what we're going to do is just kind of summarize. We're like, all right, I want to get this thing. And I'm like, ooh, I love integral test. Well, I'm going to start in this order. Even if you love integral tests, you might think about integrating it. Is that a geometric series? Heck no, right? A geometric series is something that has that exponential expression, true? All right? So I can't use this. Well, what about this guy? Because it's one of my favorites. Test for divergence. That's where you only look at the what? The sequence. Let me hide this. What's the limit of that? Is it 0? If it's 0, we can't use test for divergence. If it isn't 0, we're done. We got this problem solved. I know, that's the best. That's how cool test for divergence is. What's that limit? This diverges by test for divergence. We did it right at the beginning. Because, now let me write this down, why? Because the limit, as n approaches infinity, of 3 over 5n plus 7. And everyone, again, if you get confused on this limit, you can do L'Hopital's rule. But does anybody know what that limit is? It's got a Horace at what? The powers are the same. What's that limit? 3/5. Is that equal to 0? No. And so, there we go. I mean, look, compared to some of the things we wrote up today, isn't that short and quick? This is a rock and roll test. But it only works when this limit is what? Not equal to 0. Have you noticed most of those sequences we've seen there in a series are equal to 0? So it's not often we can use that. That's why I got it way up high. It's like, let's look for that. Because before we get lost trying to what? Oh, how do I integrate that? Is that an integration by parts? And we spend 2 hours with a long 2 pages of integrals. All right, good. Great job. All right. -1 n times 5 over 3n. And you know what? I think I'll start at n equal to 0, because anything to the 0 power is what?
Computer science notes.
Yeah, 3 to the 0 is 1, right? Any suggestions? You recognize this. What kind of series is it? Now think about this. Do you know how to integrate that thing? Do you know how to integrate that? It's like, whoa, I know. That's why we got this way up high. Let me go back. The last one was the test for divergence, but isn't that a geometric series? I can put the 5 where? If you want, you put it out here. Does everyone recognize that this is, and all that's raised to the what? M. There it is. That's a geometric series. Now if you want to make sure, the definition of a geometric series is there's always a common ratio between consecutive terms. Okay. So you want to make sure that's what's happening? Does anybody know what the ratio is now I organize it like this? What's the ratio? That's your ratio. If you can find out what's in that parentheses, that's your ratio. But I just want to point out, what would be the first term I plug in a 0? Don't forget about the 5. 5 times anything to the 0 is a what? That'd be a 5. All right, plus, what would be when you plug in a 1? What's 5 times -1/3 to the 1? Okay. But when this is a geometric series, how can I find my ratio? Take the second divided by the first. All right, what is -5/3 divided by 5? It's -5/3 times 1/5, which is -1. 1/3. Hey, cool. So anyways, that's the ratio, right? Do you remember geometric series test? Great test. If the absolute value of the ratio is less than 1, it converges. If it's greater than or equal to 1, it diverges. So what do you know about the series? Is it converging or diverging? Converging. It's converging. This converges by which test?
GST.
And all I have to do is say the absolute value of the ratio was equal to a what? 1/3, which is greater than or equal to, or greater than, right? Greater than 1. I don't want to write greater than or equal to 1. We don't have, I was looking over there, I don't have it written down, but when it equals 1, it's just going to equal that what?
It would be less than 1, not greater.
Oh yeah, you're the best. I'm writing like, it's less than, that's -1/3. We're saying the absolute value of that's less than or equal to 1. And then no, the justification, I have it all here, right? There's the ratio. It converges by GST. By the way, do you remember the geometric series test? This is the only one where we can find an actual number it converges to. Who knows the formula? What was it? First term over
1
minus ratio. What was the first term? Is it a 0? No, the first term was when you plugged the 0 in there, which gave it a what? 5. So if you want to know what this is the only one we can get a sum. It's not like we need Euler to do this for us, right? We all could do this. Like it would be, the sum would be 5 over, it actually converges to 5 over 1 minus the, so what is that? Yeah, because 1 plus a third is 4/3. And when you flip that, you get 5 times 3/4, which is, hey, who's got that math 0 button on the calculator? You could type all that in and just what? We don't have an infinity button, but Dave gets sent it to what, 100 or something? And if it doesn't work, use 20 or 30, and it should be close to that number. So have fun with that. Who's got it, by the way? Who had math 0? I don't have it on this calculator. I want to point out, I do not have math 0 on this calculator. It's on some of the newer models. I'm with you, Adam. We're like, okay. I'll just use the L1 and stuff. Hey, can I raise? Cool, almost done. Hey, Connor, so far so good? So this is what I mean. It's like, right now, we've got a bunch of these. There's only a few tests left after today. We got the ratio test, and we got the alternating series test, which is going to be rock and roll. So let me throw a couple down. I want you to tell me what you think of these. Let's do, how about cube root? We don't have to work them all out, but could you tell me stuff like this? We saw stuff like this today. Oh man. You don't have to tell me the answers, but how would you approach them all? Sometimes they start at 0, but a lot of times they start at 1. 13 over n squared plus. I'll look at all these and think about how would I approach these. Oh, I definitely got to put another one. 100 over it. But tell me, how would you approach all these problems? Tell me your method.
Series for the first one.
If you know how to integrate all these, could you do the integral test on all 4? Yes. I want to point that out first. If you're like, I can integrate that, I can integrate that, I can integrate, as long as you make sure that the terms are decreasing, you're good. Okay? But exploring all these here, and let's just see what would happen. What would you do on this one? Is it geometric? No.
Harmonic.
You're the best, Armando. HS, what do we know about this? Or hey, should I say this? This is a constant multiple of a what? It's a constant multiple. It's a constant multiple, meaning it multiplies 100 to it. It's a constant multiple of a harmonic series, so what's it doing? And I want to point out, based off your question earlier, Noah, that's all I'd have to write. It's a constant multiple of a harmonic series. This series diverges. Because harmonic series diverge. Isn't that cool?
Could you not just say harmonic series and then diverges by harmonic series?
Yep, I still want you to mention, because I had 100 with it, because the harmonic series is really the 1 over n, refer to that 100 somehow by saying it's a constant multiple. Either say it's 100 times that or a constant multiple of it. Does that help? There's something else you could have said. Isn't that a p-series? You can just call it a p-series and say it diverges by that too. What method would you use on this one? I like it too. We don't have to work it out, everyone, but I think that's a great idea. She says, look at an integral test. You notice you can do a u cell. What would you let u equal to?
3x squared.
Integral test is great if you know how to do the integrals. I mean, always have that one. It's in our bag, right? It's in our tools of things to do. So I would use integral test here. Integral test, but what's even faster?
P-series.
P-series. Does anyone already know what's happening with this?
Into the 1/3.
The p is equal to 1/3, right? Does someone recognize that? 1/3, is that less than 1 or greater than 1?
Less than 1.
Oh, then this does what? It diverges. P is less than 1. And then, no, we could write all that out. Hey, it's a p-series. P is less than 1, this baby diverges. And I was curious, now you have a couple options, which we'll end today on this. You have a few options on this one. I'm just curious, what would you use? Who would use comparison test? Yeah, I would too. I would use comparison test. I think it would be less writing. Who knows how to do that integral? You could do it. It's got an arctan. You have to take the 13 out in front. That's okay. You got to do a little arctan thing. So that's up to you how you want to do that. So have you noticed sometimes there's more than one test out there? So you bet. So just keep that in mind. Now you want to point out, if you love this limit comparison test, you got to be careful with something. That limit right there, right? It's got to be some limit that's what? Greater than 0. And you might go, well, I'll try the limit comparison test on something like this. And you get this limit equal to 1. You can see if you like that as well. Sometimes it's 3 options.
Cool.
Go ahead, Connor.
On the test, like if one of these converges, do you want us to find what they were using the remainder little thing, like what is actually
Super question. I'll be clear. I think tomorrow I'll talk about remainder, because tomorrow we're going to do another remainder. And usually when it comes to the test, it's like, should I have them do a remainder for the integral test and do a remainder for the ratio test? And I think I'll make my decision tomorrow and I'll let you know about that. So you're clear on that. You go, which one? I might have you do both. But I would just have you go out to like 10 days. Hey, I'm going to do that. And I'll write right here. This would have been what? I guess I could have done comparison test, integral test. Heck, you might look at limit comparison test, right? Those are 2 that will definitely work. There you are. Have a great day. So did that help? That's what I mean. It's like,